This is Dimensional Analysis 3, and the numbers will change for you, I think, when you do this. In this problem, I am given one piece of information, 950 square feet. I have one measurement here. The rest of this gibberish are conversion factors. So, since I only have one piece of data, I will just start with that one piece of data. You do not need to start with the data. You could start with what you want to end up with, the way I usually do, but you could also do it this way. 950 feet squared. All right. Now that data was not related to any number in here, so in the problem, so I'll just leave it there. And I want to convert this to what? I want to convert this to square meters. Let me make this a little bit bigger for you. Yeah, bigger, yeah. So there it is, square meters. So let's convert this to square meters. Well, I know how many inches are in a centimeter, and centimeters are like meters, and I know how many feet there are in an inch. So I'm going to say that there's 1 foot and 12 inches. That's a definition that I was given. This is my conversion factor. However, this is feet squared. This is only feet. So I must square the entire thing. Now, don't be doing this. Don't be like putting the little square here, because that's wrong. You need to square the whole thing, meaning it's 12 squared, all right? 1 squared. So now the feet squared will cancel the feet squared, so that's good. Now I've got inches squared. So inches squared. Now I know that in 1 inch, this is a definition, I've got 2.54 centimeters in this problem. And I'm treating this as a definition, so I do not count sig figs here. But this is inches squared, and this is only inches. So now don't be doing this. Don't be saying, oh, this is square. No, it's not. You need to square the entire thing. So it's 2.54 squared, not 2.54 centimeters squared. This is 2.54 squared centimeters squared is in 1 squared inches squared. That's how this is set up correctly. All right? And now we've got centimeters here, so I know that in 1 centimeter, it is 1 times 10 to the minus 2 meters. And how did I know that? I know that from this little puppy right here. Just like in the previous homework, look, centi means 10 to the minus 2, which is just like 1 times 10 to the minus 2. The reason why I say 1 times 10 to the minus 2 instead of 10 to the minus 2 is because when I enter this on my calculator, it's just so much easier to type 1e 10 to the, not 10, it's 1e minus 2, or 1exp minus 2, or 1ee minus 2. I think you get the point. So I'm done. Not. This is centimeters. This is centimeters squared. So this entire thing needs to be squared. Now I'm done. So let's put this out on the old calculator. 950 times 12 squared times 2.54 squared times 1e minus 2 squared. So this is 950 times 12 squared times 2.54 squared times 1e 2 negative. Oops, this is an expensive calculator, so I have to say negative 2 instead of 2 negative. And that gets me 8,826. So this is 8,826. And the only units left here are meters squared. So this is square meters. That doesn't make any sense at all. Yeah, I've done something wrong here. What have I done wrong? This 1e to the negative 2, it should have been squared. Aha! Did you catch that? It should have been squared, but I didn't square it, so let me go back and square that. How did I know immediately that something was wrong? I knew immediately that something was wrong because, just in case, let me put the parentheses here. 8,000 is more than 900. However, a foot is less than a meter. I should be getting a smaller number here than 950, not a larger number. Okay? So, what is the answer? What's the answer? It's 88. 88.26. It should be 88.26 square meters, or meters squared. Whoops, sorry. So there we are. Whoops, sorry. What am I doing? What's going on here? Okay, here we are. Let's count the significant figures. This is the only measurement in this entire bunch. There are 2 significant figures. Therefore, the answer here is really just 88 meters squared. And that's it. So I type as the answer in here. I type 88, and that's all I type. And now for number 2. Swimming pool. Here are the dimensions. How many megaliters of water? Okay, I know that megaliters are volume, and I know these are meters. All right. Looks like I have a width, a length, and a depth. So they're assuming that the swimming pool is rectangular, a rectangular prism. So I'm just going to multiply these because volume equals length times width times height. So here we go. The volume equals length times width times height, and these length times width times height are 59, 63.0, and 1. 59, 63.0, and 1. And these are all meters. So this is going to be meters times meters times meters. It's going to end up with cubic meters. So this is 59 times 63 is 3717. So this is 3717 cubic meters. Let's count the significant figures. All of these are measurements. 2 significant figures, 3 significant figures, 1 significant figure. The answer is really 4,000 cubic meters. All right, so that's the volume. It's 4,000 cubic meters. Now, how many megaliters? All right, so I need to change 4,000 cubic meters to megaliters. I'll do that over here. 4,000 cubic meters is the only measurement I have here for volume. I mean, I'm just combining these into a single measurement there. So I'm going to start with that. You don't have to start with this. You can start with what you want at the end, but it's just as well to start with that. Let's see, cubic meters. I want to go to liters, right? So I happen to know that 1 liter is 1 cubic decimeter. So let me convert these guys to cubic decimeters. So I know that in 1 meter, there is 1 times 10 to the minus 1. Sorry about that. I did it backwards. So happen to know that in 1 decimeter, yeah, you got to put the 1 on the modified unit, not the original meters unit. 1 decimeter is 1 times 10 to the minus 1 meters. However, this is cubed. That means this whole thing is cubed. And then meters will cancel. Meters cubed will cancel. Now I have decimeters cubed. Now I happen to know that 1 decimeter cubed is the same as 1 liter. I do not need a 3 out here because the 3 is already here. It is 1 decimeter cubed that is 1 liter, not 1 decimeter is 1 liter. So this cubic decimeter cancels with this cubic decimeter. But this 3, okay, this 3 is still applied to this 1 times 10 to the minus 1. Because the 3 applies to everything inside the parentheses. Now this is in liters, but they wanted megaliters. So I happen to know that 1 times 10 to the 6th, or yes, 6th liters is 1 megaliter. How do I know that? Actually, I don't know that, so let me make sure of that. Mega. 1 times 10 to the 6th. Yes, there it is. So I happen to know that 1 times 10 to the 6 liters is 1 megaliter. That's a 6, not an 8, by the way. All right, so the liters cancel here. I only have megaliters left, which is what I wanted. So the answer is going to be 4,000 divided by this cubed divided by that. So this is 4,000 divided by 1 EE negative 1 cubed divided by 1 EE 6. Okay, now I want you to notice what I did here. I did the divide sign for this, and I did the divide sign for this. I pressed the divide sign twice. See? There's my slash for divide, and there's another slash for divide. The reason I did that is because everything on the bottom is divided, and everything on top is multiplied. This is the same thing as pressing the times sign more than once. So 4,000 times 1 times 1 times 1. Divide 1e negative 1. Divide 1. Divide 1e 6. You press the divide sign as many times as you need to get all these numbers into the calculation, as long as they're not just 1. All right, I'm ignoring the ones. You don't have to ignore the ones, but you can if you like. So the answer here is 4. Does that make any sense at all? Yes, it does, because a megaliter is a really large amount, whereas a cubic meter, a cubic meter is not that big. A cubic meter is like a 3 by 3 by 3, a 3 foot by 3 foot by 3 foot box. You know, you could fit a TV. Oh, okay, I'm old. You can't fit it. You could fit a microwave oven in a cubic meter box, but in a megaliter box, I don't even know. I mean, you could fit what, like a space shuttle in a megaliter box? I don't know. I think it's pretty big. So this is 4 megaliters. Okay, so maybe not a space shuttle, but maybe, I don't know. All right. So 4 ml. Is this one significant figure okay? Yes, it is, because this is also one significant figure. All right, now let's go back to that calculation, because I used parentheses, and I want to know if it's okay not to use parentheses. So let me try that. 4,000 divided by 1 EE negative 1, the power of 3 divided by 1 EE 6 equals. Yeah, it's okay not. So when you do scientific notation on most of your calculators, not all, but most, you don't need to use parentheses if you're going to take a number that is in scientific notation to some power that is not part of the scientific notation, but it's an actual power, an actual exponent, like this guy right here, this 3. So anyways, I got 4 megaliters, and so for the answer, I'm going to put a nice little 4 there. For the last one, this is a classic NCLEX problem. You know, the nursing exam, the RN thing, a dosage calculation. So here we go. So this is the prescription: 530 milligrams of Amoxi via oral suspension. Whoa, he must have jaw problems, because oral suspension is. Well, anyways, so for every 7 hours. Every 7 hours, taking this much. So it's an oral suspension. It's in milligrams, but you don't feed the patient oral suspensions in milligrams. You feed them in milliliters. They come in like a dropper. Do you have a baby? Like I have a baby, so I know when the baby's sick, you don't weigh out the medicine in milligrams. You can't do that. You suck up the medicine in this medicine dropper, and it has markings on it for milliliters. So that's what they're doing here. So this is a liquid, which is measured out in milliliters. So every day, how many milliliters does a patient get total? Right now, the patient is getting a certain amount every 7 hours. The question here is, how many every day? Now, we know every day is 24 hours, right? So we're saying, how many milliliters every 24 hours? All right, let's try this. So I have no idea where to start. And that's because I got a measurement here, I got a measurement here, I got a measurement here, and I got a measurement here. So that's 4 measurements. Which one do I start with? No idea. Therefore, I'm not going to start with the measurement. I'm going to start with what I want. What I want here is, in a day, how many milliliters? What I want is milliliters per day. Okay, so here we go. Milliliters per day. I'll just set up the problem to go for milliliters per day. So I got milliliters per day. All right? Milliliters per day. That's what I want. Okay? Now, is there a number in this problem that is in millimeters per day? Let's see. Milliliters per day, milliliters per day. So I got 5 milliliters. Oh, I have milliliters per milligram, per milligram. So it's 5 milliliters per 250 milligrams. I don't have milliliters per day. Okay, so if I don't have milliliters per day, I'm going to circle this and leave it there because this is what I want. So, but I do have milliliters per milligram. So that was 250 milligrams, 5.0 milliliters. And let's just put this in a box. This is not part of the calculation. This is just what I want. So this is the calculation. So I've got milliliters per milligram. You'll notice that I have it backwards. It's actually milligrams per milliliter, but that's okay. For the dosage calculation, you can turn these conversion factors upside down. In any calculation in chemistry class for Chem 10, you can turn the conversion factor upside down. So this is 250 milligrams. So I just said Chem 10, but I'm also making this video for Chem 65. So in any chemistry course, if there's a conversion factor, you can turn it upside down. So this is 250 milligrams per 5 milliliters. That means I could also say 5 milliliters per 250 milligrams. There it is, 5 milliliters per 250 milligrams. Now I don't want milligrams. I want milliliters per day. I want days, not milligrams. So let's get rid of milligrams. Here's milligrams. So this is 530 milligrams every 7 hours. So this is 530 milligrams. 530 milligrams. I cannot write the number by itself because it's not how it's given in the problem. It's given in the problem every 7 hours. So it's 500 milligrams is 7 hours. 500 milligrams is 7 hours. All right? That's a conversion factor. That's how you read the problem. That's how you understand the problem. So now milligrams are out. But see, I've got milliliters here over hours, but it's not what I want. I want milliliters over days. So I got to get rid of these hours and turn them into days. Well, I already know that. There's 24 hours in one day. So hours cancel, and now everything's gone. Everything is crossed out except for milliliters on top and days on the bottom, which is what I wanted. Milliliters on top and days on the bottom. So now I know I have the right answer. So let's, you'll notice that at no point did I stop to figure out exactly what this problem was saying. The reason why is because I have looked at a lot of problems like this on sample NCLEX exams, and they are all like this, folks. You just have to know where to put the numbers. As long as you know where to put the numbers, and as long as you are able to get the units to cross out properly, 9 times out of 10, actually, I think all of the time. All of the time that I saw on NCLEX exam questions that I saw, you're done. I don't have to know Raspilin. I don't have to know amoxicillin. Later in your career, if you're a doctor or a pharmacist or a nurse, yeah, you have to know those things. But to get into nursing school or to pass Chem 10 or Chem 65, no, none of that is relevant. We're just using the numbers here and the units for the numbers, the labels here. Right, so let me get the math done. 5 times 530 times 24 divided by 250. I already forgot. So 5 times 530 times 24 divided by 250 divided by 7 divided by 1. This is 36.34. 36.34, and the only units left are milliliters per day. Okay, now let's look at the significant figures. Is this a measurement? No. 24 hours in a day, that's a definition. Is this a measurement? Yes. So I have 2 significant figures here. I've got 2 significant figures here, 2 significant figures here. And so the answer to this problem is 36 milliliters per day. Are you really going to go up to the patient and give them 36 milliliters per day? I don't know. I'm not a nurse. I'm not a pharmacist. I'm not a doctor. All I know is that's the correct answer if you're taking an exam to get into nursing school, and that's the correct answer if you're taking a chemistry course at some college. Okay? So I'm going to write 36. All right, so submit quiz. Let's see if I got these right. And 6 out of 6. That's how you should do it. Hey, by the way, don't pay any attention to these significant figures. I mean, when you write the answer, you have to pay attention to significant figures. That's how I designed the answer. However, when Canvas tells you what the answer should have been, don't pay any attention to what Canvas says, because although the non-zero part of Canvas's number is correct, if she does tell you the right answer, which I doubt she will, but if she does, she always puts these zeros at the end because she has no respect for significant figures. Why is it she? I don't know. I mean, yesterday it was he. So it's just kind of random here. But anyways, that's it. Thank you. Bye.